So topic 10-4 is graphing piecewise functions. You're going to need a pencil, an eraser, and a straight edge. And what you're going to do is you're going to do piecewise functions. So let me talk about a game that got played a long time ago. It was called red light, green light. And so when somebody said red light, you stopped. And then when somebody said green light, you could walk until they said red light again. And then if you didn't stop real quick, you were out of the game. So we're going to keep that in mind as we're going to have lots of stops and starts in this. And you're going to have to be able to figure out what goes on each time. Okay, here we go. When you are going to do these steps to graphing piecewise, this is piecewise functions. If you are given the graph, they are always going to be in slope-intercept form. And that just means that they won't be in standard and your y's won't show up on the right side of the equation. Mark the x-axis into intervals according to the domain. This hinges on domain, not on range, of the equations of the piecewise function. Lightly graph the first equation. Use a ruler to draw accurate straight lines. Erase parts of the graph that bleed out of its domain. Sometimes what's going to happen is you're going to need the y-axis to graph your line, but then your y-axis and that area isn't even included in the domain, so you're going to have to erase part of your line. Put a solid circle on the beginning or ending points if the point is included in the domain, which means greater than or equal. So greater than or equal becomes a solid dot, and then greater than has an open dot. If the point is not included, and we talked about that last time when we were doing domain and range, and so if it's not, you use an open. You're going to do these steps for every equation, and then you're going to neatly draw. So I'm going to do this one. So when it says f of x equals 2x and f of x equals 5, that's two linear lines. Okay? So how many pieces does this graph have? It's going to have 2. And are the pieces rays or segments? They're segments, and they don't have arrowheads because they have a definite start and a definite stop. And a definite start and a definite stop. So you are going to have regions, and this part is only going to show up from -5, from here, to here. Okay? So when you graph your y equals 2x, start at the origin, go up 2, go up 2, go down 2. You know, we're going to graph just like normal. And we're going to graph just like normal. Okay? And then we're going to connect it. So this actually continues on, correct? But because it says go from -5 to 2, we don't graph this part. Okay? Now, at -5 it has a closed, and at 2 it has an open. So I'm going to dramatically put that, and then I'm going to dramatically put that. That is open. Now, any question? Counted wrong. Okay? Now, there's a horizontal line from 2 to 6. Okay? But at 5. 1, 2, 3, 4, 5. So from here to here. Okay? So this is closed, this is open. I put the closed under the inequality sign. And it still remains a function, and that would be your graph. Okay, so if you notice, I do a couple of things for helping me out as I go right here and I say that's going to be a closed dot, that's going to be a closed dot, that's going to be an open dot, that's going to be an open dot. Notice that these are the same. Sometimes they will be, sometimes they won't. That just means they'll be vertical of each other. How many pieces does this graph have? Since there's 2, there's going to be 2. Are the pieces rays or segments? They are segments because they have a clearly defined beginning and end, beginning and end. Y equals x plus 3, parent function going through here. Now, the last time I did my domain first, so I'm going to do my domain first. I'm going to lightly color. There's my 1. And there's my -8. So when I go 1, 2, 3, I know that, and it's a closed dot, and it comes, and I'm graphing, and I am not allowed to go outside. I am not allowed to go outside of the, I call them fences, of the domain fence. Now, if you just leave your line like that and you do not dramatize that, I'm not sure you know what you're doing. So make sure you put those big fat closed dots and big fat open dots. Okay, the next one, y equals 10 minus 2x. So this was 3, 4, 5, 6, 7, 8, 9, 10. And I'm here. Okay, so I'm graphing it. And I'm here. And then I go down 2 over 1. And I'm starting at 1. It's an open dot. Notice I didn't plot that because it was outside. And 7. 1, 2, 3, 4, 5, 6, 7. Here's my other guy. Here's my other fence that I have to stop at. And so I'm going down 2 over 1, down 2 over 1. And that's an open dot. Make sure I get everything out here. Yes, I'm very dramatic because I do not want any questioning on whether that is. So it is a line segment and a line segment. And that's where your straight edge would come in handy. How many pieces? Well, if there's 3 things, then there's 3 pieces. Segments or rays. That's a segment because it has a clear start, clear stop. That's a segment. And it doesn't have a clear start, so that is a ray. So you're going to have an arrowhead somewhere. Okay? All right, here we go. I'm going to start with my domain. -6. 1, 2, 3, 4, 5, 6. I'll draw my little fence. You can erase the fences after, or you can leave them there. It doesn't bother me. To -2. So the first one is only going to be in there. And I'm at x plus 1, which would be here. And then it would go here. Oh, I didn't do this. And so this at -2 is open. And here is closed. I'm just dramatic, so I have no doubt. I even erased some of it, and so I'm very dramatic. You should not have any question that that is an open dot. So I have that one taken care of. -2 to 1 is here to here, which is at 5. 1, 2, 3, 4, 5. And I draw my line. And then -2 is closed. -1 is open. I erase so I can see that it's open. And then -2x plus 1 is greater than 3. 1, 2, 3. So it's over here. It's over here. And so I have to go at 1 and go down 2 over 1, down 2 over 1. That's where it starts. And it is, that's closed. And then it's array. And so this is array. What am I looking for when I see these graphs? I'm definitely looking whether they are having closed dots and open dots where appropriate, arrowheads where they're appropriate, and graphed correctly.